Welcome, my dear friends, to this important lesson in which we will expand the database with tables of orders, transaction, and details for each order. Imagine managing a clinic where every process is seamlessly connected. A patient orders medication, and the system automatically logs the transaction, updates inventory, generates a detailed bill, and even integrates with insurance providers to handle claims. This level of automation ensures operational efficiency, reduces errors, and provides a superior patient experience. For example, if a clinic doesn't have a robust system for managing orders and billing, patients might face delays or discrepancies in their invoices. However, with a well-structured system, all processes from orders to transactions to billing are handled effortlessly, ensuring that the clinic runs like a well-oiled machine. In today's lecture, we'll dive into implementing orders, transaction, and billing in our clinic management system. This will enable the system to handle critical workflows, such as medication orders, payments, refunds, and insurance claims, making it a comprehensive solution. Learning objectives. By the end of this lecture, students will be able to 1. Remember the purpose and importance of orders, transactions, and billing in a clinic system. 2. Understand how these models interact with existing tables such as patient and medication. 3. Apply Entity Framework Core to create models and define relationships. 4. Analyze the impact of transaction and billing management on clinic operations. 5. Evaluate how migrations ensure the database schema reflects our code. 6. Create and extend the database schema using configuration classes and migrations. Lecture outline. Step 1. Creating models for orders, transactions, and billing. Step 2. Configuring relationships using configuration classes. Step 3. Integrating the models in clinic context. Step 4. Generating and applying migrations. Step 5. Conclusion and evaluation. Step 6. Preview of the next lecture. Step 1. Creating models for orders, transactions, and billing. Let's start by creating a class called Order by going to the Model Class library. Then we create the class and name it Order. Purpose: tracks patient orders, who ordered, when, and status. Benefit: simplifies order management and links orders to patients. Public place order. Public int order ID gets set. Order ID unique identifier for the order. Public int patient ID gets set. Patient ID foreign key to the patient table. Public date time. Order date gets set. Order date. Date when the order was placed. Public string status gets set. Status of the order. For example, pending, completed. Navigation properties. Patient navigates to the patient. Transaction connects to the relevant transaction. Step 2. Configuring relationships using configuration classes. We start by creating a class called Order Configuration. Purpose: defines rules for the order table, including primary keys, relationships, and constraints. Why? Ensures the order table is correctly structured. Specifies that order ID is the primary key. Defines the relationship between order and patient. One-to-many to maintain data integrity. Why is this important? Has key. Defines order ID as the primary key. Property. Makes status mandatory and limits its length to 50 characters has one and with many, establishes a one-to-many relationship. A patient can have multiple orders. On delete prevents deleting a patient if they have orders. Now, we have here error, cause of the error. The patient class is missing the navigation property orders. With many P or go to P dot orders references a property that does not exist. How do we solve this problem? Follow me. Add navigation property to patient. Public iCollection orders get set. This links patient to orders and ensure order. Class links to patient. Here, links order to patient. We will also make settings for the order details class called order detail configuration. Purpose configures the order detail table which stores individual items in an order. Why? Ensures order detail ID is the primary key. Establishes relationships between order detail and order, many to one and medication, many to one. Enforces cascade delete. So when an order is deleted, its details are also removed. Why is this important? Hasky defines order detail ID as the primary key. Has one. Links the detail to the parent order and medication. We will also make settings for the transaction class. We will name it transaction configuration. Purpose defines settings for the transaction table, tracking payments and refunds. Why? Ensures transaction ID is the primary key. Links transactions to patients, one to many. Restricts deletion of patients with associated transactions to prevent data loss. Why is this important? Hasky defines transaction ID as the primary key. Property ensures type and status are mandatory and limits their length for data consistency. Has one. Establishes a one-to-many relationship between patient and transaction. On delete prevents deleting a patient if transactions are linked to them. Correct the configuration. Builder has one, it go to it. Medication dot with many M go to M transactions. Navigation property in medication dot has foreign. Key it go to it dot medication ID. Dot on delete. Delete behavior dot restrict. Why? Navigation properties are required for entity framework to correctly map relationships. Adding these properties ensures the one-to-many relationship between medication and inventory transaction works seamlessly. Finally, we will make settings for the class called billing and insurance. We will call it billing and insurance configuration. Purpose configures the billing and insurance table for handling insurance claims and bills. Why? Defines billing ID as the primary key. Links bills to patients, one-to-many, and transactions one-to-one. Ensures insurance and billing data is accurately related to patients and transactions. Hasky defines billing ID as the primary key. Property ensures status is mandatory and sets a maximum length for insurance provider. Has one. Establishes one-to-many relationship with patient, one-to-one relationship with transaction. On delete. Restricts patient deletion if bills are associated. Cascades deletion of bills when transactions are removed. Same thing we have here. Problem in not defining property. Cause of the error. The patient and transaction classes lack the required navigation properties for billings, which causes the error in the with many P go to G dot billings. Solution: add navigation property to patient. Public iCollection, billing and insurance billings get set. Links patient to billing records. Add navigation property to transaction. Public iCollection, billing and insurance billings get set. Links transaction to billing records. Step 3. Integrating models in clinic data context. Now, let's go to the file called clinic data context and include these new classes as dbSet. Public dbSet order orders. GetSet public dbSet order details. GetSet public dbSet transactions. GetSet public dbSet billing and insurance. GetSet. And in our model creating, we added that model builder dot apply configuration new order configuration. Model builder dot apply configuration new order detail configuration. Model builder dot apply configuration new transaction configuration. Model builder dot apply configuration new billing and insurance configuration. Step 4. Generating and applying migrations. When working with Entity Framework Core, migrations are a powerful tool that allow you to define and apply changes to your database schema based on your code. In this step, we'll break down what happens during the commands add, migration, and update database, explaining their purpose and process. Add migration command. Add migration add orders transactions billing. What it does: compares your current models and configurations with the existing database schema. Generates a migration file in the migrations folder with two methods. Up specifies the changes to be applied to the database, e.g., creating new tables. Down specifies how to revert those changes, e.g., dropping tables. Purpose prepares the database schema updates based on your code changes. Update database. What it does: executes the up method from the migration file, updates the database schema, creates new tables. Example: orders, order details, transactions, billing and insurance. Adds relationships, constraints, and indexes as defined in your models and configurations. Updates the EF migrations history table to track the applied migration. Purpose: synchronizes your database schema with your code. Why these steps are important: add migration documents the changes to your database schema in a controlled way. Update database applies those changes to the actual database, ensuring consistency. In summary, add migration creates the plan. Update database executes the plan on the database. Now, after doing the migration, we want to make sure that the new tables have been created or not. Let's go to the database, then go to the name of the database associated with our project, ClinisDB, and let's see the tables. Very good. The new tables have been created successfully. They are orders, order details, transaction, then billing and insurance. Conclusion. In this lecture, we defined and explained the models for orders, transactions, and billing, configured relationships using modular configuration classes, integrated the models into the clinic context, updated the database schema through migrations. Evaluation. Do you understand the purpose of each table? Can you configure relationships using configuration classes? Was the migration process clear? Preview of next lecture. Next, we'll focus on user management, roles, and permissions to secure the clinic management system. Stay tuned. See you in the next lecture. Bye.